that part, but hey, gotta do what you gotta do, and that is start remembering stuff. And we got this, and we'll minimize that. And I always think I'm so good and get everything prepared, and I don't. So which one is this? That's not the one we want. Nope. There we go. Okay, so the assignment, it's 2 files. Should be active now. If you want to start opening it, you can. If you want to wait, you can wait. You go into files, kind of like we have, and store them in a folder, and the folder is called Excel and Stats. Pretty straightforward. There are 2 files. One is a Word document, one is an Excel file. You're going to be using both. In fact, what you'll be doing is following the instructions of the Word document and then using the Excel document to actually do the procedures and do the steps. The Word document, it is like cooking and or chemistry. You follow each step. So long as you follow each step exactly, the next step makes sense and you follow that step. Now, mind you, this is written for Windows. If you're using a Mac, you just have to make those modifications and switch over. If there's any confusion with that, things like Command-C versus Control-C for copying something, Command-V versus Control-V for pasting something, don't hesitate to ask. We could translate it out. And I don't know why I still have it in Windows, considering I don't use Windows and I don't really like them, but I do. So that is that. There are only some parts that you are going to submit. Everything else you're going to do, you have to understand, you have to make sense of, but you're not going to submit. Other things that I can mention off the top of my head. Nope. You don't have to do anything away from class. In fact, I would encourage you not to, unless you don't get done with things by next Tuesday. And the main reason is there are a few times where I need to call you guys out so we can sort of talk through an idea. And generally what I like to do is I like to wait until there's a certain threshold of people who've hit a certain step within the exercise and then call people out. Makes sense? Questions with that? Okay, as you work together, I would highly encourage you guys to share your screens, talk. You only need to submit one assignment, and you're going to start to learn something from me pretty clearly. I never want to see your raw data in terms of final product. But your raw data is what you manipulate, what you work with, what you change with. And again, we're going to keep to Excel for doing this. And as an example, this is one of the spreadsheets that make up your raw data. You'll download that, you'll mess around with it. If you make a mistake with it, the original file is always going to be in Canvas. You can always go back to it. But you're not going to show me a table. You may show me a figure, but you're going to bring it out. You're going to be putting it into Word, and you'll just see those instructions. They are right there. Now, a few small caveats. One, Excel is a very powerful tool. And you really do want to get comfortable with using it, no matter what you decide you want to do later in life. If you are very curious, then having tools that let you answer questions are brilliant. And Excel is one of those pieces. I will mention that if you are interested, I would quickly transition into something called R. And this is a language that allows you to do statistical analyses and where there's a lot of limitation in Excel. And if you're a Mac user and you're using an old version of Excel, then you're going to be stuck with a program called Stat Plus that are both annoying, limited, and boorish. By contrast, R is an open source language, which means it's free. It also means that it's upgradable by every person across the planet, much like Wikipedia. And therefore, any tool, any question, any basically modeling or statistical approach you might need has likely been coded and developed by someone so that you can use their insights to address whatever you want to do. And as an example, this is just a little graphing GIS package that came in R. These are some of the codes that you built. They can look very daunting, but there's just a learning curve and you get very used to it. And you copy and paste bloody codes from everybody. So it's a community of thieves who just take their ideas from each other. And then by sort of using data that we collected from a study in 2017, we're able to basically identify the locations within Cape Coral and create some representations of those organisms across that area. Something that you would not be able to do in Excel, and something that would cost you as a student $100 annual subscription in GIS. And if you're a professional, a few $1,000s in annual subscription to use GIS, or you can use the open source free package R. So if you ever do get intrigued, or you could see yourself going into a field where having some quantitative knowledge is there, start making that transition. I know some faculty are starting to use it in their classes, which is awesome. If you get to take one of those, and if you are interested, there's always biostats we teach each fall, consider taking it. But in this class, we're not going to worry about that. What we're going to use for our stuff is use Excel, unless you're already familiar with R. And if you're already familiar with R, you are more than welcome to use that approach in anything that we do. Questions? Okay, what I would encourage you, and I'm going to give you 3 minutes, is in the chat, if there's individuals that you want to work with, reach out to them privately. Because again, you can work in groups of 1, 2, 3. No more than 3 people. It's really kind of, it doesn't make sense in terms of this environment. And the ideal is honestly 2. And the reason it's 2 is if you work with 3, you either might have a parasite who basically just takes all of your work and sits there like a little leech in your neck, sucking out all your efforts, or you might be the parasite. And you think you're getting all that reward, but you're actually not learning a bloody thing. 2 ends up being perfect because then one person can be typing out answers on Word, and the other person can be sort of addressing issues and trying things in Excel. You'll have the opportunity to share your screen, which is that green button at the bottom of your Zoom, so you can see what each other are doing and you can pop back and forth. And it actually works really, really well online. In fact, I've discovered that both teaching R as well as teaching this exercise are much better in a virtual environment than they are in person, because of that ability to sort of work directly from your computers. If you have a partner, then what I need you to do is to change your name by going to the 3 dots in the top right-hand corner of your image. And then in that name, you'll see a place where you have rename. And then at the end of the rename, I want you to put a dash and either put self, because you're going to be by yourself, or put who you're going to be working with. And again, as a reminder, Connor, Alex, Cortland, and Dakota, you guys don't do any of this and just stick around. And I'm going to give you your instructions in a few minutes. And while everyone's doing that, I'm actually going to make those guys co-hosts. Okay, and I don't see Dakota yet. And if you could use the dash versus an and so I know what I'm looking at, it just, if I see the dash, then I know I'm looking at a name next to it.
Does anybody
Everyone
else
set?
want to be like in a group with me and Millie?
In fact, why don't I walk away for 2 minutes and you all can just talk and set up your groups. And then after that, I'll give you all a break for like 3 minutes so I can set up the breakout rooms. All right? I'm gonna go get a little snack.
Okay. Cindy got to me first. I think we can only do 3. I'm sorry.
Crystal, if you want, you can join me and Carla. If you don't want to be alone.
All right, why don't you guys go take a 3-4 minute break? I'll set up the breakout rooms and then we'll get people started, okay? All right, whenever you guys are ready. Why don't you guys turn on the camera, make sure everyone's back. There's 1 or 2 people who didn't say their preference and there was nothing next to their name. So I have them in an individual breakout room by themselves. I'm going to keep people in individual breakout rooms so that Cortland, Connor, and Alex can sort of jump between rooms and help. They may come into your room. If they are, they may ask you some questions, or if you have some questions, they can help you try to get past a particular stumbling block. They're not there necessarily to give answers, but they are definitely there to sort of help you figure out how to go through whatever steps there are. Make sense? The other thing I want to remind you is starting next week, we'll introduce the scientific biography. And then that is another assignment where you have the choice to work between 1 to a few people. So if you already kind of have a sense that you do want to work with someone, please feel free to start that dialogue. And the one statement I'll make in terms of individuals who want to work by themselves, brilliant, do it, that's awesome. But those students tend to be very, very bimodal. The student that works by themselves many times turns in by far the best work. You know, whether it be an assignment like this, or whether it be the biography, and they're excellent. It doesn't mean that individuals that work in groups can't turn in something excellent, but you know, you get an individual who does it by themselves, just amazing stuff. Or the person who does it by themselves can turn in really, really problematic things. And you can kind of think of why. If it's just you and you're relying on all of your effort, it's more work. But the more important thing, it's harder to think through different ideas because you're only relying on yourself. You always have that choice, always give you that option. But I just sort of introduced that now, and I'll probably repeat it again later. Any questions? And God, I'm hoping you can hear me because I just realized I didn't say anything. All right. So here you go. All right, gentlemen, go and turn on your audio. We'll have that little chat.
Excuse me, sir. What with my partner?
You don't get a partner. Now, you guys are automatically going to get 100% on this assignment, and you don't have to turn it in. What I really want you guys to do is kind of what we do with the. I don't have to record this part. Record. Share screen. Yeah. You guys can canvas, right? Then you. Oh, good. Thank you. And exaggerated yeses are much received and very subtle head movement stuff. Give me a big old yes. Thank you. So long in the two videos that I made them back. We really go through step everything we're looking at in this exercise, in addition to a few things.
Dr. Gunnels.
Yes, sir.
You're lagging really bad.
Oh, lagging further, just you, Alex.
It's
Everyone.
Yeah, we're all
Lagging
struggling.
for everyone. Oh. Well, that's gonna be great because there's nothing I can do about it.
Is it microphone through your earphones?
It's the best.
Hmm.
I got the mics. Disconnect.
Yes.
That sounds a lot better.
Yeah, it's better already.
All right. Well, y'all might be hearing a bunch of construction in the background, but I'm glad that works. So
Fine.
you can hear me better. Is that right?
Yes.
Yes.
And therefore, everyone says thank you to who?
To Connor, thanks.
Well, I was going to give you both Alex and Connor. Yes,
Oh.
exactly. Always speak up. Never sit there. If there's something weird, let's try to figure it out. So, gentlemen, both, thank you. On Canvas, there's a bunch of long in the tooth videos that sort of walk you through how to use Excel, how to do different functions. There's a lot more information in these than is required of you in terms of this exercise, but one, they can help you for the exercise. And then two, if you're trying to sort of learn a lot of shortcuts, they're there. On that note, steal Connor, Cortland, and Alex for shortcuts, other ideas, because you want to make this as good as possible for you. Make sense with that? Any questions? Okay. So let's see. Nope. That's not what I want. This is what I want. There we go. And let's go here. Let's start with Casey. Casey. What is a null hypothesis? And then after that, Casey, I'm going to ask the next person, and why do we care?
It's been a hot minute since I did stats, but isn't the null like your assumption, like what you think will happen?
Ooh, that tends to be the alternative. There are a few situations where We do think the null is going to occur, but for the most part, that tends to be the alternative. What's a null hypothesis, Crystal?
You said, why do we care about the null hypothesis?
So what is the null hypothesis?
That is a great question.
It is a good
Is it-
question.
Is it like, is it the another option for a hypothesis? Yeah.
Okay, I'm going to send you guys out into your breakout rooms for 5 minutes. I'm going to leave you with 4 questions. What is a null hypothesis? Why do we care about the null hypothesis? What is an alternative hypothesis? Why do we care about an alternative hypothesis? If you're in a group, you can just stay with your group to sort of discuss and figure that out. If you're by yourself, there's this beautiful thing called the internet. You can use that, figure it out. But what is a null? Why do we care? What's the alternative? Why do we care? Make sense? Oh, Julie, thank you for putting it in the chat. Okay, I'll see you guys in about 5 to 10. Connor, Cortland, Alex, you guys don't go out for this one. Set up a timer for 5 minutes.
Okay, 5 minutes and counting.
The data occur completely randomly.
Oh, lovely. So the alternative hypothesis is the biological set of predictions. The null hypothesis is the pattern is random. It predicts randomness. So there'll be a difference, but it's a random difference, not a biological difference. There'll be a relationship, but it's a random relationship. It's not a biological relationship. There'll be an association, but it's a random association. It's not a biological association. So we have the alternative that says a biological prediction. Why do we care? Because we want to know the biological patterns. There is a hypothesis that describes random patterns. Now, here's the kicker. And let's go to Connor for this one. Do I see Connor? Oh, I do. Yeah,
Yes.
Connor, why do we care?
Well, the whole point of running a statistical analysis is trying to see if there is relationship between the two variables you're comparing and see how they are related or unrelated. So if you're trying to relate two biological behaviors, or for instance, like you're trying to see if there is limited like similarity, and if there isn't, then you have to test a different hypothesis. Is that even close?
Not really. No, sorry. It
That's okay.
has all the themes of the right idea. But there are 2 or 3 things in stats which are just fundamentally weird. This is one of them. Why do we care about the null, Alex Marsh?
Well, I feel like nothing is random. And
Really?
yeah.
Really?
Well, I remember in biostatistics, there are no coincidences, which, somewhat has to deal with random stuff. But there's a degree of randomness, but I feel like patterns are what we focus on. So having that randomness as a baseline almost is an important thing to have. So you have almost that baseline. Okay, I see you have a bunch of examples in there. Is there another one coming? Got any more?
I'm really not working on it. There's a lot of random patterns.
Okay, well, there are randomness, but I feel like the randomness can serve as almost a baseline for what patterns we're looking at.
You're getting so warm. And Connor, what you said is sort of what we do with the stats, which is true. But the reason you care about the null, we use statistics to evaluate the null, period. Statistics tell us whether we can reject or do we have to describe the null. That's what statistics do. At least that's what old school stats do. If you ever use a p-value, that's what you're doing. You're evaluating the null. So why do we care about the null? Because that's what we apply statistics to. That's why we care about the null. If we can reject the null, we discuss and describe the alternative, which was the point that Sam started us off with. And Connor, you explained that part very, very well. But the null is what we're actually testing. And that's weird. That's weird. I like this example. I know I use it all the time, and therefore, if you know me, you've seen this example. There's a pen. We're going to use a little bit of physics. What should happen to this pen if I let go of it? What would you predict? It should fall. And is that a null hypothesis or an alternative hypothesis?
Alternative.
That is an alternative hypothesis. Brilliant. That is an alternative hypothesis. Now, in statistics, we are evaluating the null hypothesis. So one hypothesis is that it should fall. In fact, we can even put why it should fall because of gravity, right? Okay, so now, if there's a null hypothesis, what is the likely outcome of a pen when I let go of it? What's one possible outcome of the pen when I let go of it?
Nothing happens.
Nothing happens. I let go of it and it stays still. It doesn't move at all. What's another possibility if I let go of the pen? And for this one, I'm going to call on Ella.
It flies upwards.
It goes upwards. That's brilliant. Megan, what's another possibility? If it's a null and therefore it's completely random, it could stay still. It could fly upwards. What's another possibility?
It can move to the side.
It could move to the side. That's awesome. Olivia, what's another possibility? It can go up. It can stay still. It can move to the side.
It could have no idea. Go diagonally?
Go diagonally? Absolutely. Taylor?
It could start flipping.
Ooh, we could get flips going on. Alex Marsh, did I see your hands up?
Yeah, it could turn into a second Billy Gunnels.
It could turn into a manifestation of me. So there would be a mirror image of me, but no longer a pen. I would basically be holding a mini me in. It's random. All outcomes are possible. When we use old school stats that have p-values, we are testing the probability of a random event occurring. That's what we test. If every time we let go of the pen, it falls, we have evidence which will reject the null. The more times you do this, the more evidence you have to reject the null. If we reject the null, we then describe the alternative. And that's what we're doing with old school stats. Again, any statistics with a p-value. You're evaluating a random outcome. If you have a certain p-value, you have to describe the random outcome. There's no pattern. There's no difference. There's no relationship. Something's going on. Gravity doesn't seem to be operating. If you have data that firmly rejects the null, you describe the alternative. The physical prediction, the biological prediction, the chemistry prediction. Does this make sense? So each time we do a study, especially a study that uses old school statistics, we start off by identifying our null and our alternative. And then we test the null. So last questions before I send you guys back out. Julie, Perel, what is a good null or alternative hypothesis in this case? I think Julie stepped away for a second, so I'll come back to her. Caitlin, Sapka.
Hello.
Hello. Give me either a good null for the study we're doing with the Excel file right now, or a good alternative hypothesis for the Excel file that we're using right now.
Let me look at it again.
Wait. Millie, you're up. Cindy, you're up. Just so you guys know your batting order, so you can sort of almost get.
Okay, I've gotten to the second part of the assignment, like doing the t-tests and the averages and the sum and stuff. But do you want it for like relative to the biodiversity, like for any of them, or?
I don't know. You haven't told me yet.
Okay. I guess you could say wild biodiversity is independent of urban biodiversity. Is that
Perfect
right?
null. There's no difference between wild and urban biodiversity. Great null. Notice you have to do it. You're not going to submit this part, but you do need to do this. That was excellent. Kaylin. Millie, give me the alternative then.
There is a difference between the two.
There is a difference. And then last but not least, Cindy, which of those two hypotheses are we going to test with a t-test?
Don't you test the null to see if you reject it or not?
Absolutely. We're going to evaluate the null. Depending on what we do with the null, we then infer information about the alternative. And this is why we call it inferential statistics. We test the null, and depending on what we do with the null, we infer information about the alternative. Okay, why don't you guys take a break for 5 minutes? In fact, take a break for 8 minutes. Come on back at 12:13. Turn off your video, walk around, get some movement, and then I'll send you guys back out to breakout rooms. Resume the recording, and I'm going to share my screen. And I'm going to bring this over. You guys can see the Word file, right?
Yes.
Awesome. Pop that, see this. And then while I'm thinking about it, I do take attendance every day. If you're not here, you lose a percentage point out of the 10% for attendance. If there's a mistake in my record, just tell me, and we'll fix it. Sometimes juggling, I may miss someone. And when we're in this situation of sharing a screen, I don't get to see your names. So I may miss it. If they're not here, well then, doesn't matter either way, right? All right. So I have a few little questions, and why don't we start with, well, actually, let's start with Corlin. Corlin, what's a p-value, man?
A p-value is the chance that you are making an error, like the percent chance of making an error when you are deciding to reject or accept the null hypothesis. Or
99% perfect. Yeah, and so statistical language. That was awesome. So that's actually one of the big surprises with statistics, especially old school stats. You're not evaluating the alternative hypothesis. You're not evaluating the biological prediction. We are running a test to evaluate the null hypothesis, which is very weird. I can empathize with that, but that is the reality of the situation. So as Connor said, a p-value is the probability of making a mistake by rejecting the null hypothesis. So if a p-value is very small, then there's a small chance of making a mistake if you reject the null hypothesis. If the p-value is large, then there's a high probability of making a mistake if you reject the null hypothesis. So please, Heather, remind me, what is a null hypothesis? Heather, do I see you? Okay, well then let's start with Megan. Megan, please remind me what a null hypothesis is.
it's the hypothesis that you are testing, it typically there isn't a difference between the two like data sets that you are testing.
Perfect. It's the random hypothesis. It's the hypothesis that there's no difference, no pattern. It's the hypothesis that whatever we see, it's just a random phenomenon. So p-value tests the null hypothesis. And it tests whether we can reject it or not. Now, can someone tell me, what do we do if we reject the null hypothesis? What do we infer?
You're accepting the alternative.
We describe the alternative. And I changed the language ever so slightly. It's not that we accept it, it's that we describe it. We sort of, that becomes our working hypothesis. That's what we use. So Caitlin now is perfect. So a statistic evaluates a null. If a p-value is very small, then we can reject the null and describe the alternative. If a p-value is high, then we describe the null. And that's stats. If that makes sense to you, ultimately, you've gotten most of what is called Popperian statistics. And then it's just random different tests, and it's not that much of a deal. But if you can get that concept, that's sort of the underlying principle behind most introductory stats. All right. Now, the reason I'm showing a screen is I asked this sort of arcane question. Which p-value is more conservative, a one-tail or two-tail p-value? And by conservative, I mean which one's more rigorous, which one's more scientific. And if you ran the t-test, you probably notice a one-tail sample, the p-value is smaller than the two-tailed sample. And the reason it is a one-tailed p-value only considers one possibility. When we did this test using these insects, we're looking at both resident and transient insects, insects that live on palm trees and ones that can fly among palm trees and other objects. Residents are the ones that live on palm trees, transients are the ones that fly back and forth. With a one sample test, you're only considering one of those two outcomes as being possible, as being the larger group. And there's no chance at all that the other possibility could be the larger group. So you're making a decision before you even run the statistics about what the pattern is going to look like. And as a result, it's a lot easier to show a significant pattern, a biological pattern, than with a two sample. Because a two sample, you don't care before you collect data which of them could be larger, which one could be smaller. You, when you collect the data, treat both of those possibilities as equally valid. Because we could describe our alternative hypothesis as there's a difference, or we could describe it as residents have higher biodiversity than transients. That's one alternative. And a second alternative, transients have higher biodiversity than residents. There are two different ways of looking at that difference. With a two-tailed p-value, you consider both of those ways. With a one-tailed p-value, you only look at one of those ways. And therefore, which one's more scientific, which one's more conservative, which one's more rigorous? A two-tailed. And for your own work, and for everything we do in this class, you should always use a two-tailed unless you have some extraordinary reason not to. Because what you're doing when you use a one-tail is you're kind of cheating. You're making it a lot easier to reject the null hypothesis and describe the alternative. Does that make sense? Okay.
Yes.
So y'all ran a test. And I ask you to write a result sentence. You know, do you reject or accept the null hypothesis? And then based on that, you write a sentence. Like all good science, you have to have evidence for whatever you say. That's why we use citations. That's our evidence. That's why we use statistics. That's our evidence. So you're going to make a declaration. That's your result sentence. And then you're going to put in your evidence. And this is the pattern for putting in your evidence. You put in this test, the test stat. That's a t-stat. You put in the degrees of freedom, and you put in the p-value. And the reason we do that is that the p-value is determined by the relationship of the degree of freedom to the test stat. So when you report it, you want to report all three pieces. You want to report the test stat and the degrees of freedom because that shows where the p-value comes from. And for someone who knows statistics, they would be looking for those things. There's a few extra reasons. One, the degrees of freedom show you a measure of either the number of groups or the overall sample size. And then the t-stat shows you how far apart or close the two populations were. Now, you may not sort of see that in the numbers, and that's fine. You really would want to take a statistics class to sort of start seeing that information. But regardless of whether you can visualize it or not, you always show these elements. Your stat, degrees of freedom, and the p-value. The other thing we do is we write a sentence. And could you, Audrey, have you done this piece yet?
Yeah,
Great. Can you give me the sentence you wrote?
I don't know if it's right, but I just wrote that we, I don't know if it's right, but said we would fail to reject the null hypothesis that there is no difference in biodiversity between resident and transient insects on sable palms.
What was your p-value?
1.44 to the negative 20 or e negative 20. So yeah.
Okay, so there are two things wrong here. And that's why we have a class. No big deal. First thing, is that a small p-value or is that a large p-value? And for that, I want Natalie. Is 1.4 times 10 to the negative whatever. Is that a small p-value or large p-value?
It's small. It's a negative exponent.
It's a negative exponent. It's very tiny. It's almost zero. And this is one of the things that you do have to memorize. And there's very little in stats you have to memorize. But you got to memorize this point. The p-value describes the null hypothesis. It describes the chance of making a mistake if we reject that null. If the p-value is very, very small, are we going to make a mistake by rejecting it? The answer is no. Since we're not going to make a mistake if we're going to reject it, can we reject it? And the answer is yes. So if the p-value is very small, reject the null hypothesis. If the p-value is large, describe the null hypothesis. Is someone? Hey, Bill, you have a good day, okay? Those are the guys doing the construction. I will still be at home tomorrow. Yay. So, what is the threshold number in terms of p-values?
0.05.
0.05. It's arbitrary, but it has logic. A gentleman by the name of R.A. Fisher described it back in the 30s. And he decided on 0.05 because it was about 2 standard deviations away from a mean in a normal distribution. That has logic. It's arbitrary though, because he could have said on 0.01, which is closer to 3 standard deviations. So we use 0.05. If it's smaller than 0.05, reject null. If it's larger than 0.05, describe the null. So now, with that information, Audrey, do you know what you need to correct with your sentence?
Yeah, I think so.
Okay, well, you work on that. So I'm going to come to someone else. Mackenzie, we still here?
Yes, we're still here.
Great, give me your sentence.
I haven't wrote a sentence yet, but based on the information I got, I said we will reject the null.
Okay.
Because of our p-value is less than 0.05.
Is that an accurate statement? I would say yes, it is. That is a perfectly accurate statement. Fantastic. Carla, do you like that statement?
Yes.
No.
No.
So we'll try again. Theus, do you like that statement?
No.
No. Good job. Good job. Mackenzie, what you said was 100% accurate. Because of the small p-value, we can reject the null hypothesis. That is absolutely correct. But Carla doesn't like it. Theus doesn't like it. I don't like it. And I'll tell you why I don't like it. Because I am biased. I don't like statistics. I do statistics all the time, but I'm a biologist. That's what I like. So should we be writing about the statistics or should we write about the biology?
We should definitely write about the biology and describe what that means more. I just haven't wrote my
Oh,
sentence
Mackenzie,
yet.
that was awesome. That's exactly what I wanted to hear. That was perfect. So can someone please tell me the biology? Schuyler, give me a good biological sentence.
Of why we would reject the hypothesis.
Well, a good result sentence, a good biological result sentence with a very small p-value. Where the biodiversity of the transient insects was much higher than the biodiversity of resident insects.
So we will. I mean, could you just say like that, like we will reject the null hypothesis because the biodiversity of the transient and the resident insects, sorry,
Have no significant
had no significant statistical difference.
Yeah.
The first third, the second third, loved it. The final third, terrible. What did you do in the first third?
I didn't
You wrote out the stats. Don't
Yeah.
talk about stats. Talk about biology. What did you do in the second third? You talked about biology. That was awesome. What did you
Okay.
do in the final third? You went back and you started talking about stats again. Don't talk about stats. We
Okay.
have the stats. That's our evidence right here. We're going to have evidence. Our evidence is the stats. We're leaving it in the parentheses. Don't put it in your sentence.
Okay.
So we're back at the beginning. Casey, give me a good biological sentence. I don't see Casey now. Look at this. It's like in like Friday afternoon or something. Crystal, you're up, buddy.
Can you ask the question one more time?
A good biological sentence that describes the relationship between transient and residential insects at sable palms.
Resident.
Yep. So have you gotten to this point yet?
No, we
Okay.
are.
All right. If you're not at the point that, then you can't sort of describe it out. So you're fine. Sam,
My group also didn't get to it because we're having some difficulty with the t-test.
no, then you're fine. You're fine. Does someone want to volunteer?
Could I try?
I would love it.
Okay, so my assumption would be to more like explain everything. So we are going to reject the hypothesis that there is no relationship between, sorry, I'm gonna pull up my stats really fast, that there is no relationship between resident biodiversity and transient biodiversity. And we're rejecting that because our statistics supports the hypothesis that there is a strong relationship between them both.
I love the last part. When you write a biological sentence, keep it very simple. And that's where a lot of us get into a mistake. The evidence in the parentheses, that describe your stats. You don't have to write that out. What you can say, because it's a very small p-value, is you could say the biodiversity of transient insects was larger than resident insects on sable palms. Period. Describe the biology. Stats are a tool. All we want to do is use them as a tool. When we see the tool, we can look at the means. The mean for transient was much larger than the mean for resident. And therefore we can say, because of a small p-value, they're different. And since the mean of the transient was higher, we can now just make a simple sentence. The biodiversity of transient insects was higher than the biodiversity of resident insects on sable palms. And then you put the information in parentheses, T equals, whatever that number is. Degree of freedom is equal, whatever that number is. The p-value for the two-tailed test. And think of it this way, and this will be the last thing I say for today. Think of how you would describe this biological pattern to a parent, a grandparent, a friend who has no background in statistics or biology, and describe it that way. Don't worry about describing the statistics. That's our evidence. That's in the parentheses. You don't have to write that out. Just describe it in a very clear and as simple as possible way. The biodiversity of transient insects was larger than the biodiversity of resident insects in sable palms. Does that make sense? You're going to be doing another one in urban and wild biodiversity. If you give me an answer that talks about the null hypothesis, a significantly small or large p-value, what am I going to learn about you? What will you be telling me? You will be telling me that you are planning on changing your major and moving over to stats, and you will be leading biology because you're so excited about the statistics and the statistical pattern, and that's cool. I'll be sad to see you go, but totally fair. I get it. Any last questions with this? Okay, if you have questions you want to stick around, please do. We will come back to this on Tuesday. I would encourage you to get through this step of urban and wild before you depart. So I'll send you back out in your breakout rooms, but whenever you're at that stage or beyond, go ahead and feel free to stop. Any questions? Okay, if I don't see you, have a lovely weekend.